All right, let's do a problem here that was mentioned in one of the last video on pulleys when we were discussing the davits for lifeboats and that sort of stuff. And it was the block and tackle. So here's an example of this, and we'll walk through this. This is moving into the next section in statics on equilibrium. How do we determine forces when everything has to be in balance? So in this problem, Jack wants to pull himself up to the roof, but needs assistance as he does not have enough strength. Luckily, he's got a block and tackle pulley that comes with a bosun's chair. Your job, find the tension in each rope where the dotted green line is, and the force P that Jack would have to exert to pull himself up. So, that being said, with all good statics, we start with a free body diagram. So, and we're going to take a look at free body diagram across dotted green line, and I'm going to show you something else here to make your life a little simpler. So if we did this as a G and a G, then we could write this as FBD at, now let's do regular at cutting plane G dash G. Okay, and that is probably the better way to do this. So that is the one I'd check off, and we'd call that's what it is. So that's what that green plane becomes, is G dash G. It could be any letter. You could use AA, BB, CC. You just use G. It's a random letter that we pick, and it's a green line, so we can do that. All right, so to solve this one, we need to look at is this. So we have pulley A, all right, here, and we got a rope there and a rope there. And then we have a rope off the pulley B that comes down, and this hits the chair over here, and at the bottom of the chair is 210 pounds. Okay, so we're going to keep that in mind. That's one of the forces we're going to need. But now here's the thing to think about. That force has a tension, that force has a tension, and that force has a tension. So there's forces on all those. I'm going to use tension because literally as the weight hangs on this rope onto pulley B, it's going to be stretching, so it's going to be in tension. This rope off A to B will be in tension, and so will the one A up to the anchor point at the ceiling there. So that's the direction we're going to choose them in. We're fairly good. Now write yourself a equilibrium equation. Let me put that in black. Write yourself an equilibrium equation that makes sense. And we're going to choose the y direction going up. And then we're going to do a sum of forces in the y direction. There are no forces in the x direction on this problem, so we're pretty good. And literally, here's what we have. We have 3t minus 210 pounds. All right, and that's going to be set equal to 0. And if we solve for t, we're going to get 210 pounds divided by 3, and we will get t to be 70 pounds. Okay, and we got our answer. So that's our tension in each one of those. All right, and it's as simple as that. It really just, if 210 pounds is pulling down, each of those ropes has to hold 70 pounds going up, and we will get our answer. Now, that gives us the tension. That was the first part of this, but we really want to know what force is Jack going to have to pull up. All right, so we really are looking at this free body diagram next. Okay, so free body diagram of pulley A. All right, and it comes like so. So let's put a circle in there, and I'm just going to go to green here, and we know that's not green. We know this, and we know this, and we know we got this. Okay, that's our P unknown, and we know each of these is 70 pounds. Actually, I guess I should put those in black. Okay, so really, again, sum of the forces in the y is equal to 0. We literally have 70 pounds plus 70 pounds minus P equals 0. Solve for P, and we're going to find out that we have 140 pounds, not 170 pounds, 140 pounds. And that's how much weight Jack must lift in order to do that. Okay, real simple. That's an introduction to pulleys, but as long as we're here, I think I'm going to do a real brief introduction into the basics here. All right, so let's do this. If we have, we can do one of three things. So when in doubt, find the sum of the forces in the x direction, the sum of the forces in the y direction, and then down the road we'll do sum of the forces in the z if we have them, and then literally you can start looking for some of the moments in any direction. Okay, so we can also play those up, but that's generally what we're looking for. So no matter how we do this, always first steps in any problem. Find the sum of the forces in the x, the y, the z, and the sum of the moments in any direction you need to find them for. But generally, if you do this, you're going to be able to start almost every statics problem you're ever going to see the rest of your time. All right, I'll catch you in the next video, and we'll do some more examples with equilibrium, but that's what we're looking at.